Hey guys, Ms. Gosling here. In this video, you're going to learn about solenoids. By the end of this video, you'll be able to determine the magnetic field due to a solenoid. So let's go ahead and get started. And we're going to start by talking about what on earth a solenoid is. Now, you may not recognize the term, but you have probably seen one before. A solenoid is pretty much any coil of wire with a current running through it. So on our solenoid here, we have this nice curl of copper wire, and what we would do is we would hook this up to a circuit, so some sort of voltage source, and that would cause a current to run through all of my wires. So what's the point of a solenoid? Well, a solenoid is a really good tool for having a consistent and strong magnetic force traveling throughout it, created by a circuit. So it's stronger than the force traveling through a single wire because you have a bunch of wires that are all coiled together. It also is a good way to direct the magnetic field of those wires. And we're going to go ahead and take a look at what that looks like in the very next slide. So what does the magnetic field of a solenoid look like? Well, first, it depends on the direction of the current going through our solenoid. So I'm going to say that my current is going up on the right side of my solenoid and coming out on the left side of my solenoid. So our current is kind of going up and then around and around and around and around to the left and then out. To figure out the magnetic field of the solenoid, what I'm going to do is I'm going to do the right hand rule on my wire. Now on my loop of wire, if I stick my right hand around it, on this first loop of wire, my magnetic field is going to be pointing this way inside the wire and this way on the outside of the wire. And what's really nice about the solenoid is inside the wire, all of my field lines are actually going to line up. So I can draw the magnetic field of the solenoid like so. Now, what does this remind you of? Hopefully, it reminds you a little bit of a bar magnet, where we have one side where all of my magnetic field lines are going in and another side where my magnetic field lines are going out. So one way to think about this is a solenoid is a way of creating a magnet within a circuit, and a magnet without having to make a permanent magnet, that has a defined north pole and south pole. So instead of a single coil of wire, where you may have your current going out on one side of the wire and into the page on the other, and so it's going around the wire, now we have a magnetic field that is not circling around the wire of our current, but is actually going through that solenoid, because all of the different magnetic fields of each loop of wire in that solenoid is going to add up. So we have our magnetic field lines going out of our north pole and into our south pole. So we can kind of model our solenoid in many ways like a traditional magnet. So takeaways. Solenoids are made up of coils of current carrying wire, so coils of current, and we can use the right-hand rule to determine the magnetic field due to a solenoid. So there you have it, guys. Here's your extension on magnetic fields in wires. I hope you enjoyed, and I hope this added a little bit more to your understanding of wires.